Good morning, everybody. First of all, very warm welcome to all of you in this BSc second year, and hopefully, all of you have passed at least in physics, or hopefully, all of you will be with a clear mark sheet. Now, myself, Dr. S.D. Chauhan from Department of Physics, Adarsh College, Hingoli. Might be my name is important to introduce because of number of people even don't know who I am. So it's a fact that the first year students, many more students have not attended the classes previously. So that doesn't matter. So let's move to our session. That is, I have paper number 6, and the paper name is Wave and Oscillations. Now, what exact still there are 4 units, and first one unit is waves. And before going to start, what exactly in this your waves and everything, what the 4 units are there. Important factor is I want to tell you that all these 4 units are totally based on the waves and what exactly the vibrations, how the waves are going to be created, what exactly the disturbance. Wherever the one word wave comes, that time the wave, it's not single come, it always comes with the particles vibrations, and the wave, that means it is having the velocity. Of course, the wave is definitely, when we can say, it also contains the amplitude, frequency, time period. All that basic parameters are very much important to understand. If you understand this, all these basic parameters, then it is very easy to understand what exactly the relationship, as far as equation point of view. You can see the different waves in the oscillations are also how it is correlated with that. So in this first unit, waves, we will see introductory part as well as the wave velocity and the particle velocity. See, the wave is the different thing and the particles are different. When the wave is moving with some particular distance, that is your wave velocity. And velocity, in simple way, we are all aware about that, it is nothing but to be displacement with respect to time. When I am talking about any bike, then it is velocity of that bike. When I am talking about the wave, then it is velocity of that wave is to be there. Wave is going to be transfer moving from one place to another place, that with respect to the time, that is nothing but to be velocity. Now the wave is having velocity, it doesn't mean the particles are moving from one place to another place. The particles are only vibrated at their own stage, and that is how the particles are moving from the top mean position and the down and up to again mean position. That means the vibrations and the displacement of the particle is also there. That means these particles are also having the velocity. So what exactly the difference in between the wave velocity and the particle velocity, that we will see in this session. Also we will see differential equation of the wave motion, what exactly the wave motion is to be there, and how it is correlated with in the equation point of view, what exactly the parameters are there, that we will differentiate and we will calculate. Secondly, again, the energy plane progressive wave. When the wave is transferred, that means to be the transferred, that means there is energy, as this energy in that progressive wave, that means going from progressive propagation of the wave is to be there. And that plane, wave is having the energy, and that how to calculate the energy, how much amount of energy it contains, that we will see in this energy of a plane progressive wave. And we will calculate exactly what amount of the wave energy is to be there. Again, moving forward, the equation of motion of the vibrating string. See, the wave is generated in generally we have seen that in a sea we have seen the waves. Even if a single pot and having the water, if you drop any stone, you will find the waves are going to be generated. Even if you have taken one rope and it is fixed to the one point, and from the other side if you are moving up and down, then the waves are also going to be generated. Now, if suppose you have taken one string, that is means to be a one rubber or anything material, or the you can say wire is to be there, and that is fixed to both the side, and it becomes as a string. And if you disturb at its middle stage or knock it, then you will find the vibrations are going to be generated. As the vibrations are generated, wave is going to be generated. And that's what in the string what happens as far as the wave is going to be generated. And related to that equation of motion of vibrating string, that is what the difference as far as how it is correlated with the your wave equation that we will see. Again, I already told you, whenever we discuss about the waves, there is a frequency period, that is the time period of the vibrations of the particles or the wave is to be there. And in this case, when we are learning for the vibrations for the string, we will also learn what exactly the frequency and the time period relation for the vibrating string is to be there. So string is nothing but both the sides of the wires are going to be fixed, and that is what the vibrations are going to be generated. And in that case, how, what amount of the frequency, or how to calculate the frequency and the time period in that case. This is all about your first unit is to be there. In the second unit, that is called as a your stationary waves are to be there. Now exactly the stationary waves are simply when the two waves are going to be superimposing each other. And in that case, when these waves are going to be superimposing to each other, in that case they cancel crust to crust, trough to trough, or it increases crust to crust or trough to trough. That things will give you overlapping of such a particularly two waves in opposite direction in a straight line. Superimposition is giving you a stationary waves. Now in this unit, that is stationary wave, we will see a very fundamental and very important factor, that analytical treatment of the stationary waves, close end and the open end pipe at the other end. That means the if you have taken a hollow cylinder, that is called as a your open end organ pipe, and if you have closer that one side, that is becoming to be as a close end side. So in this case, if you are going to be generated a wave, that will have the same time period, frequency and the amplitude. That means when the waves, and that is for the generation for the stationary wave, it is very much important, when the two waves of the same amplitude, frequency and time period are going to be superimposing in opposite direction, then the stationary waves are going to be generated. And in this hollow cylinder, that is open end organ pipe, when these two waves are going to be superimposing, that means the stationary waves are going to be generated. In that case, what will be the analytical treatment, what will be the node and antinode positions, and what exactly the energies at that points, that particularly we are going to calculate for the close end and the open end organ pipe. Again, we are also learning in these stationary views the investigation for the investigation of the pressure and the density changes at the displacement nodes and the antinode points. In the stationary views, we will learn basically where the wherever we learn the views, it is the node point and the antinode points are important factors, where the amplitude basically amplitude velocity is maximum, where the strain is going to be maximum, and antinode point or the node point, what exactly the max or what exactly minimum, that also we will learn. In that case, we are going to find out what amount of the pressure and density change for these different places, that is the node point and the antinode point, that we will also discuss in this part. Again, distribution of energy in the stationary waves, as in general wave we have seen, if the propagating wave is to be there, In that case, the energy is going to be transferred from the one place to another place. In that case, again, when the stationary waves are going to be generated, what exactly the two waves are going to be superimposition. So no doubt there will be no transfer of energy, but definitely energy is going to be generated. So what amount of energy is generated at the node point, what amount of energy is generated at the antinode point, that we will also discuss in this point, that is distribution of energy in the stationary waves. Although the wave is going to be stationary, but the energy is going to be different at different points. That means at the node point and that antinode point, the energy is going to be definitely different. That we will calculate in this distribution of energy in a stationary wave. The next part, that is clearly mentioned already, that energy is not transferred in a stationary waves, but that we have to prove in the equation point of view. And to prove this part, that is the energy is not transferred in a stationary waves, that means the two waves of the in the opposite direction and having the same frequency, amplitude, time period, that means to be suppose two trains are superimposing each other, definitely you will find no will move forward, no will, this one, not the left one, not the right one, are going to be forwarded. Both will stop at one end when the having the same speed is to be there. Now in this case, the energy is max when the explosion or the two trains are going to be superimposing. That means the energy will be generated max, but this energy is not going to be transferred, and that is what the energy is not transferred in a stationary wave, that we will learn in this your second unit. Now moving forward for the third unit, that is the free and forced vibrations. Now you will get a little bit confused about that, this why when we are learning the waves and here is the free and forced vibration, something different. See carefully, this wherever I am talking, or wherever the vibrations are there, the waves are there, because without vibrations the waves are not going to be generated. A disturbance in a steady medium, that will definitely gives you the vibrations, and that vibrations are nothing but to be periodicity, and that will give you nothing but to be your waves are to be there. So what in a simple pendulum, if suppose how it is going to be related with that, how when I am you have done the experiment in the 12th standard, that a simple pendulum, when you disturb it at a certain level and release it, the bob will move from that is SHM, simple harmonic wave motion, that moves from the extreme position to it comes to the mean position, again goes to the extreme position, again comes to the mean position, and again up to the another peak max position. So these oscillations are going on, that is nothing but to be free vibrations are to be there. So as these free vibrations are there, damped vibrations are also the part of it. Now if suppose after some time, if you have given the simple pendulum displacement, you will find after a half an hour or the 10 to 15 minutes, these oscillations will die, and you will find the bob will be at the center at the rest position. But because of there is a air in this atmosphere, that will give you resistance force for these particular oscillations. Now when I am talking about undamped vibrations, that means I have taken this simple pendulum in the vacuum, and when there is no friction or the external force to stop this your bob, then the vibrations or the oscillations will be continuous, and that is what undamped vibrations are to be there. So looking forward again, the damped vibrations, how it is to be the undamped vibrations and damped vibrations are to be there. Damped vibrations, no doubt, again it will give you related with the when I am using that pendulum in a air. Now again damped SHM in a electrical circuit. Now this is how your syllabi is going to be. Somehow last year this point was not there, and this time again this point is going to be introduced, that is damped SHM in a electrical circuit. Now how it is correlated, simple harmonic motion, that is repeated and periodic motion, that's what we called it as a SHM, that is simple harmonic motion. And damped means in the air you are taking that your oscillations. and how it is correlated with the electric circuit, how the electric circuit and the SHM is having the similarities. That is going to be in the equation point of view we are finding out. And what relations are there for the critically damped, undamped, or the critical damp positions are to be there. So that is somehow we will see in uh, this damped simple harmonic motion. Another one is to be forced vibrations. The forced vibrations are nothing but to be the oscillations are not if oscillations are slowly reducing, slowly coming less one, and I am externally I am again applying the some force, that is nothing but to be forced vibrations are there. Now in this case, if suppose these forced vibrations are there, what exactly oscillation part is going to be there happen, and vibrations are going to be changing, and how the equation is to be different equations for these forced vibrations are there, that we will learn in detail. Again the resonance and the sharpness of resonance, how it is going to be generated when the force of vibrations are given. With this case, again the what exactly the phase of resonance is to be there. So related with the examples of force and the resonant vibrations also we will see. The resonance is nothing but one simple pendulum is having its own vibrations, and if I am introducing another one simple pendulum, and means that one for two rows I am applying two simple pendulums are there, and I am displacing only one and releasing it, then the whatever be the vibrations this one simple pendulum will get, it will definitely give it to the another simple pendulum, and that is what the transfer of the particular case where the resonance is going to be generated. Means one simple pendulum's vibrations are transferred similarly to the second one, and that is what the vibrations transformation that gives you the resonance part and the sharpness of resonance, and how in that case what is the phase of resonance is to be there, and that we will see in the force of vibrations what exactly the resonant part comes. So this is all about your basically third unit. Now the last unit is quite interesting and the very easiest one, that is acoustics and the ultrasonics. So what exactly the acoustics is meaning to be there. So as we are discussing the your waves are to be there, so acoustics that means to be sound waves. So again you will say what exactly difference, the waves are there, either it is sound waves or electromagnetic waves are to be there. Now acoustics are related with the sound waves part, and the ultrasonics are also to be the waves. What exactly that means to be there, how it is going to be different from that we will see. So wherever the acoustic comes, that means to be reverberation, and what exactly the reverberation means is to be there, you are listening my sound clearly. If there is a classroom and all the 10 or the 20 or the 50 students are there, all will listen whatever be the lecture is going on at 1 second or that same time, and that is nothing but to be this maintained by this reverberation, that is persistence of the sound is to be there. It is not like that the front students will heard my sound first, and the last on the last fifth students, fifth 50 number students who is at the backstage, he will listen after some time or after a few seconds. It is not like that. When I use the word acoustics, everybody listen it or everybody hear it at the same time, and that is maintained through this reverberation. So we will see what is exactly reverberation time is to be there. Again with this reverberation time, the derivation of the reverberation time, the Sabin is the one scientist who first discovered this relationship to find out the reverberation in this your hall, or what the different type of the concert halls or the auditoriums are there. Now basically if you are students from the rural area and you are coming to the Hingoli for the living, and when you are searching in the room, that time you have seen when the room is completely empty and you talk in that room, you will find that echo is to be there and your sound is going to be vibrated, or the echo sound is going to be generated. But when you come to living in that room, you will not find such type of the echo or the sound vibrations or the reflection of the sounds are there. The some sort of absorption and the reflection of the sound is to be there, and that is going to be adjusted, and that's why in the living room you will not find any echo or likewise that. So this is what the requirement for the reverberation of the time. And the Sabin is the first scientist who this found this reverberation formula to find out the reverberation for the different materials. And with this case, the absorption coefficient is the one of the part. That means the every material, that means the side walls, roof, floorings are having the different types of the materials. And even if windows, your door are made up of the wooden, and your side walls or the room is made up of with your constructions with the your cement and sand is to be used. That means materials are different, according to that surface areas are also different, according to that nature of the every material is different, and due to that absorption of the sound for the each material is different. So it is important to find out this absorption coefficient for to calculating the reverberation time. And the Sabin is also given contribution in this, and that's what we are going to calculate, this absorption coefficient relationship. Again, determination of absorption coefficients, that is the part. Again, acoustics measurements. Now acoustics measurements are basically what exactly this requirement to measure the how much sizes are to be there for the maintaining the good acoustics, that part is to be there. And that is what the conditions for the good acoustics designing of an auditorium. So what if you have seen in the auditorium or any theater, the if you have seen the movie, that you will find that the theaters or the concert halls or the auditoriums are made up of in a different shape, and again their roof is to be different, their side walls are going to be different, and their sitting arrangement, everything is going to be calculated for the acoustic maintaining. And that is what nothing but to be acoustic designing is to be there. So this is all we will learn in this acoustic designing and good conditions for the acoustic designing. Secondly, again here the ultrasonic waves. These waves are the supersonic ultrasonic waves. What exactly the ultrasonic waves? For to understand that, you are also aware about that human being are having some particular range, that audible range. That means 16 hertz to or 20 hertz to 20 kilohertz is nothing but to be your human being audible range, you can say. In this case, if the range is wave is going to be max, wave is going to be having the sound waves are greater than this wave, that is to be your ultrasonic supersonics or the ultrasonics, that we will see in detail. Again, the what exactly this method to generate these ultrasonic waves are to be there. And first one method is the piezoelectric oscillations are to be there, and with this case the ultrasonic waves are generated. There is another one, magnetostriction method is to be there, or oscillation is to be there, that generates your um, ultrasonic waves are to be there. Now detection of ultrasonic waves are also we will learn in this your syllabi. And lastly, acoustic grating is also the part for this particular acoustic grating is nothing but to be related with the some sort of, you will find when you will do the experiments related with the second year part, then you will find out what is grating, and that part related with this acoustic grating is to be there. So lastly, applications of these ultrasonic waves. There are a number of applications right nowadays. This ultrasonic gun is also going to be used for your dentists are going to be using these ultrasonic guns, and number of applications for the kidney stone operations are everything where these ultrasonic waves are going to be used. So more or less we have covered the basically what exactly your syllabi is to be there. Before going to this conclusion part, first I want to tell you that these four units totally that is first one is view, second one is stationary view, third one is your free and forced vibrations and oscillations are there, and fourth one is acoustics and ultrasonics. If you look at this, all the four units are basically with the view, nothing is without view. That means we all are learning complete view in this semester. So once you understand this generation of view or the total life of this view, it is very easy to understand the different parameters related with this view, because in day-to-day life without view nothing is going to be possible to live your life. So that's why these views are very much important in our lives too. So if you learn basic through this is somehow arranged, this syllabi is to be very good for the your this semester. And lastly, uh, with this part today we are concluding our session, but from tomorrow we will start our first unit, that is what is mean by to be view and how the views are going to be generated, what exactly basic things for these fundamental things of the view, that we will see. And here lastly we will conclude with these reference books. And reference books, the one of the book which is to be very much famous, Waves and Oscillations, Brijlal and Subramaniam, which is the one of the best book that if you will take, that will cover nearly complete syllabi. Secondly, textbook of sound with the theory of oscillations and the waves, that is Khanna and Bedi. That is also important book for the your oscillation free and forced vibration oscillations unit is to be there. A textbook, third one is a textbook of sound, that is Subramaniam, Brijlal and Subramaniam is to be there. Again, this one is the nice one. Sound, M. Ghosh, few parameters you will see in the related with the acoustics part, you will see in this unit, in this sorry book. And next one book is the textbook of sound, that is Sharma and Saxena. This one also book is useful for the acoustic designing and ultrasonic things are to be there. The last one, that is sixth one book, is to be physics of vibration and waves, that is this one is John Whaley's publication, and this one book is also very nice. So these all are the reference books. First two books are very much important, that we will see available in our library too, or online you can also take the copy with from this your net. And lastly, uh, thank you, and be at home and be safe. So next part we will see tomorrow. Till then, stay to you, be safe, and be at home. Thank you.